If you think of, say, like a social network, there's even access controls there. Am I allowed to see this person's profile? Am I allowed to see their messages? Am I allowed to DM this person? Those kind of things. Those are authorization rules and logic that has to be implemented somewhere. And your options really are to spend time hard coding that, or to take a much more kind of externalized approach and a policy-based approach, which is kind of, at least I think and we think, is a more scalable way of doing things rather than hard coding this logic over and over.
This is DevOps Paradox, episode number 297. Streamline access control using Cerbos. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Victor, when you sit down to start writing an application, you always start working with authentication and authorization in mind, right?
Absolutely not. Think of me as an anarchist. I believe in freedom for everybody.
Even freedom for the people that are going to be hacking your systems.
Yes. I'm a nice person.
I guess if there's no blocking strategies in place, you're really not hacking, are you? On today's show, we have Alex Olivier on from Cerbos. Alex, how you doing?
Hey, great. Thank you. Thanks for having me. Hope everyone's had a good new year.
Yeah, here we are, January 8th. I can't believe it, man. We're ready to go, January 8th. Yet another year closer to retirement, maybe.
Oh, we can all dream.
We can all dream. Cerbos is not an authentication tool, but it is an authorization tool.
Yes, and those terms keep getting muddled up even to this day.
Maybe explain what's the difference, just in case somebody's not aware of it.
Yeah, absolutely. So, we all love our acronyms in the industry, and unfortunately, authentication and authorization is one that gets shortened down to AuthZen and AuthZ, which is even more confusing, if you ask me. And yeah, so Cerbos is in the authorization space, but when you start to think about building those systems, when you start implementing an application, one of the first things you kind of worry about is, who is this user? Who's his identity? Are they authenticated? So authentication, with that N, is about challenging the user to provide some sort of credential, verifying that credential, and you go, cool, you now know who this person is, you know exactly who they are, or who's they're pretending to be at least. And if to think of an analogy, imagine you're at an airport, you're trying to enter the country, you give someone your passport, they look at the photo, it's like, cool, we've authenticated that this is who you are, we've got a document that verifies it. Authorization is the next step. It's like, cool, there's some software, you now know who someone is, what can they actually do? Are they allowed to view a particular part of the application? Are they allowed to export some data? Are they allowed to approve an invoice? And that's where you're basing a decision based on who a person is and also what they're trying to do, and then the rules behind it and authorizing them to do a particular action, whether it should be allowed or denied. So to go with the travel analogy, it's now that customs person at immigration deciding whether you're allowed to enter the country based on visas or whatever the such that you have. So authorization is, now you know who someone is, what can they actually do inside of a system?
Okay, we're baselined now. We know the difference between authn and authz, or authz for people like me, because Z still doesn't make sense. Z is the evil guy from, what was the Japanese anime show? Power Rangers.
Yes.
Z, yeah. So there we go.
It's also a letter, honest.
Oh, okay. So Cerbos, there is a company, but there is also an open source project, and you can check it out. Apache licensed, everything's good. But again, why should we even care? I mean, you gave us the reason why we care. But really, why do we care about authorization? I mean, authentication is easy. It's like username, password. That's authentication.
Yep.
Can at least do that much. But then as soon as you cross that point, it's like, okay, then what can you do? But why do we even care about that anymore? Because it's all zero trust nowadays, right?
Well, I mean, a key part of zero trust is you need to verify. You never trust, always verify that a user is not only who say they are, but verify they're allowed to do the thing they're trying to do. And if we could live in an idealistic world, I'm a software developer at heart. If I was just building a system, I'm going to assume, well, if this person is either an admin or they're a user. So an admin, they can do everything. If they're a user, they shouldn't be able to do a subset of that. But any system or any application you're building that has any concept of workflows or users that need to interact with each other, you now need to start overlaying and interacting and putting into place sort of limits and controls based on roles. I'm sure many are familiar with the term RBAC, role-based access control. And then there's ABAC, which is attribute-based access control, which is now where you need to start putting those controls and limits in place. And there's many reasons why you'd need to go and add in authorization. Typically, if you are building, say, a SaaS platform, you might have different pricing and packaging for how the features are accessed. So now that is a type of authorization. You need to gate features based on what package someone has. If you're building a system that is going to be run in different parts of the world, you now need to put gates and controls to restrict access based on data locality laws. If you are running a system that is running in like a regulated industry, like having strong access controls in place to make sure the right people can access, say, a bank account or are allowed to view the transactions of a bank account. These are all types of authorization logic which you need to have in place, and not only have in place, but also be able to prove to auditors and compliance teams that you have these strong access controls in place. So you need a way of defining that doesn't necessarily mean a team of engineers is spending hours and hours and hours and days and months building the system over and over. But these are controls that every application needs the moment you have multiple people working together on top of a data set or a set of resources.
Am I understanding it right if I would say that it's more often used for internal applications than public facing? Like, I have a website or something like that. I'm more likely to just authenticate somebody and that's it. And then if it's internal application, I don't know, like AWS, right? They probably need to have more fine-grained control of what each user can do, right?
Yeah, it's good to kind of bring up AWS. So if you go back to sort of why we started building this open source project, the whole Cerbos policy decision point is previous businesses I've been in, we were basically building applications that were both internal, but also we had like an external sort of SaaS platform as well. And naturally, inside of there, we were having customers that had requirements around like, okay, I want to onboard my employees, I want to employ my marketing team or my sales team, but they all need to have different views of the data or different accesses in place because, we're as a business, we can't shoehorn everyone into, viewer or editor. They need to have much more fine-grained access. So at the time, we went actually to AWS and said, like, we're already using AWS IAM. Love it or hate it, is a very structured way of defining your access policies and such. And we were like, we kind of want this, but for our own software. Will you go and open up AWS IAM as a service, which at the time it fell on deaf ears and it didn't really go anywhere. So having then spent hours and months and days building these systems ourselves into our own platform, we're like, why are we building the system again? Because what happens is you go and implement this logic once, 6 months down the line, the authorization logic has to change and evolve because you're now selling to different regions. You have different product packaging requirements. You have different needs to lock down access. And so you end up having to rebuild this system over and over, and it just wastes time. Ultimately, this applies a lot for internal systems, internal teams and internal tools. But even external applications, if you think of, say, like a social network, there's even access controls there. Am I allowed to see this person's profile? Am I allowed to see their messages? Am I allowed to DM this person? Those kind of things. Those are authorization rules and logic that has to be implemented somewhere. And your options really are to spend time hard coding that or to take a much more kind of externalized approach and a policy-based approach, which is kind of, at least I think and we think, is a more scalable way of doing things rather than hard coding this logic over and over.
Why are we building this system again?
Exactly.
That's the famous last words, right? But yet you built it again.
Yes.
With a twist, which is the policy-based.
Yes. So going back to kind of previous lives, I was constantly reinventing the wheel where we had all this logic that was hard-coded, and we're like, well, if we were to do this for first principles, this sounds like a standard component that you'd want to have potentially as like a service or some sort of library that you just reuse over and over. And this was 4 or 5 years ago now, and we kind of looked at the market and open source offerings, and there were a few kind of policy engines that allow you to do certain things or certain use cases. There's ones that are very focused on infrastructure. There's ones built into all these cloud platforms we use. But where I always came from was from a like end user application or an internal platform type application use case where your permissions super important. And you want to be able to not only have those permissions in place, but also have them in a way that was human readable and accessible, and had things like audit logs baked in order for you to tick off all those compliance needs. So this recurring nightmare of previous lives where we were going through and getting our SOC 2 and ISO compliance, and every year an auditor would appear in the office, and I got dragged down to some dark, dingy basement, and I had to go through all the audit process and demonstrate things with those. And a big part of that was access controls. And not only saying we had access controls, but being able to prove that. And one of the things that I would end up having to do is like sitting there trying to grep through application logs in S3 showing, look, we got a 401 or a 402 or a 403 based on access logic, etc. But now what we be able to actually demonstrate, okay, here are our policies. Here's how they're defined. They're defined centrally. They're auditable, versionable. And then also here are the resultant decisions that these policies has made, and really be able to give a view that was very clean of, okay, at this time, this user tried to do this action, this resource, approved or denied by this particular policy. Why we ended up building Cerbos is a very focused project around that kind of application layer authorization. So we're not worrying about the infrastructure. Your cloud providers and such will have authorization tools in place. Kubernetes has things like emission controllers to get stuff into your cluster. What Cerbos is really focused on is that end user application level emissions in a way that you can ultimately set it up once as a development team and then hand off the policy management and authoring to the product team or the security team, or really those people that hold those requirements, rather than constantly have to go back to a development team to get involved to update this logic. And we wanted to make sure it was easy to adopt, so we open sourced the entire policy engine.
So with having the engine open sourced, and I've been taking a look at it, if you go out to GitHub, just look for Cerbos. It's Cerbos. It looks like Cerbos, but it's actually Cerbos. You should have added an extra S. That would have made it easier. With Cerbos, I've got the policy engine there. And let's say I want to go ahead. I've got my internal application, right? It's the normal thing I've got to do. And we've done exactly what you were saying. We were hard coding things. We were doing annotations that set in certain, not the actor. What's the word I'm looking for? Who are our four big pieces? Because if you go out to the site and look at Cerbos, the principle, the action, the resource, and the policies.
Yep.
And then you have your engine that helps manage that. But the principle, I know the principle. That's me. That's the authentication side, right?
Exactly.
Right. And that's just keep it simple. That's authentication. Yep. But then action, normally I might have, again, I said annotated a function with some sort of, you must be this level. You must have this role. Let's say I wanted to go ahead and rewrite my app to use Cerbos. What pain and suffering am I going to go through in order to make that happen?
Yeah. So if we kind of think of what's involved in a request coming into a system and then ultimately an action happening. So you set up your internal platform, you got some internal service, it's exposing some sort of API or a web app, let's say, to an internal team. So that is going to make requests to your backend. So that request is going to come in. It's probably going to have like a token associated with it, JWTs, those kind of things as a way of identifying it. Just a side note, I still believe to this day that the HTTP spec is incorrect because it calls it an authorization header when I'd argue it's actually an authentication header. That's beside the point. So that request comes in. It will hit your service. Inside of your service, you now essentially know three different things. You now know who the principal is because you've got that identity, you've got that token. That token contains scopes, potentially, or further claims that might be involved in authorization. Based on the actual request path, you know kind of what action they're trying to do. So it's a get request to some, get me this purchase order type endpoint, and you know what resource they're trying to access. Like, again, because of the request, okay, they're trying to view, edit, update, delete, approve, deny, comment, flag, whatever those actions are on a particular resource. And that service that request is being handled by is most of the time the source of truth, the system of record for that entity or that resource. So in your service, you can go and fetch that record from the database. Now, what you sort of have to change is inside that handler. If we were to go with an attribute-based access control check rather than just a simple role-based check, in your request handler today, if you were like hard coding it, you would have a load of if statements and case switch statements. So if the user's role is admin, then allow the request through. If the user's role is manager, then only allow under XYZ circumstance. That is code, that is logic that you end up having to potentially repeat across different code paths or even different services that might be in even different languages. So you have to re-implement this logic in a number of languages. The Cerbos approach is, okay, let's take all that logic and decouple it from the actual application. And the way you decouple it is you convert it into a policy. Now, we didn't want to go and invent a whole new policy language or anything like that. We didn't want to have you a steep learning curve. So Cerbos policies are just YAML files, which some people will love, some people will hate, but we think it's a standard enough format that people kind of understand, and there's a rich ecosystem of tooling around it. And essentially, you take that logic that you need to have in place and convert it to a Cerbos policy, and a Cerbos policy defines, here are the different resource types in my system. Here are the different actions that users can do upon a resource. So view, create, update, delete, approve, flag, comment, whatever those actions are, and don't get hung up on HTTP verbs. Actually think about the real business action that someone is doing. And then for each of those actions, you state, okay, under which condition should these actions be allowed? And this is where you can do a simple role-based check. So you say, okay, has a person got a role of editor? If so, allow the action. And that's where you start out. In reality, though, most systems are doing what we call attribute-based access controls, where you're not making a decision just on base whether someone has a role or not. You're actually making a decision based on the context of who the user is and the specific instance of a resource that they're trying to interact with. And the best example of this is you could never have a role of owner, because to have a rule that says you're the owner and therefore you're allowed to say delete a resource or edit a resource, you now need to do a check, which is, okay, is the ID of the principal or the ID of the user making the request equal to the owner ID attribute of the specific resource they're trying to access? And now you need to start putting conditions in here. And this is where you have policy-based attribute-based access control. So in Cerbos, the way you define those is we use another open source project called Cell, Common Expression Language from Google. So you would have a rule that says, okay, to do the edit action, you must have the role of a user and the condition of your principal ID must equal to the owner ID of the resource must be met. Cerbos itself is fully stateless, so it will evaluate that and come back with a decision. So on the application side of things, in that request handler, request comes in, you've got the identity. Rather than having all that logic coded, you would integrate the Cerbos SDK, and it would make an API call out to a Cerbos instance. So you run and deploy a Cerbos PDP, a container inside of your environment. If you're in Kubernetes, we recommend running it as like a sidecar to keep the network overhead as little as possible. And in your application code, you simply pass to Cerbos, here's the user, their identity. So you've got that token, you might have some claims in, etc. Here's the actual resource they're accessing. So you would have queried from your database. You would have got the fields that you need for authorization purposes. You pass that to Cerbos, and here's the action they're trying to do. Cerbos itself then just evaluates your policies based on those inputs, comes up with an allow or deny decision, creates an audit log of that decision, and then what comes back to your application code is a simple Boolean, allow or deny, and then your application can then respond as it should. And what this all now means is your authorization logic is decoupled out. It's in these static policy files. These policy files can be checked in as another asset in your repo. You can version control them. You can write full tests against them, which is something we've also open sourced, a whole test suite harness. And then the actual integration work now means, because that check integration call has been done once, you can iterate and evolve your authorization policies independently of your application code. And then any system that's calling for Cerbos to make an authorization decision will always get the latest answer based on whatever those policies are. And you, in theory, never have to then touch that integration code again.
How big is the overhead? In terms let's say a request might ask for one authorization or 5 or 10, right? Because
Yes.
It's going through different functions and what's or not, right? All those are making requests to the server. And then I have infinite number of requests, right? Multiplied with whatever number of... How much does it cost me?
Yeah, absolutely. So a bit of context. So my background, as well as the rest of the founding team, we've all come from businesses where we're doing large-scale data processing systems. So the last system I worked on, we were doing about 50 billion requests a day through it. So I've made pretty much every mistake possible when it comes to distributed and high throughput, low latency processing systems in the past. And one of these bottlenecks we kept having was around authorization. And so that really put us in a mindset of like, this thing needs to be performant. Every decision we've made with how Cerbos is architected is focused around performance. Because unlike authentication, which you can do once and get a token valid for, say, 30 minutes, authorization is in the blocking path of every single request. Going back to your point about like zero trust earlier, never trust it, always verify in every single call. So the way Cerbos is architected is predominantly around speed and around reducing latency as much as possible. So it comes down to some of the design decisions. So Cerbos itself is fully stateless. The only thing that's loaded essentially into the application is the policies themselves. All the other context is provided at request time from the application. So this now means Cerbos itself doesn't need to hit disk. It doesn't need to do any I/O. It doesn't need to go out to some external API to make a decision. It can do everything in memory. So everything, when Cerbos evaluates a policy, it's doing it sub-millisecond every single time. Anything beyond that is network. And so how do you go and optimize the network side of things? Because Cerbos is stateless, it's essentially horizontally scalable, infinitely scalable. So you're in a position where you can decide, okay, we'll go with a sidecar approach. We'll go for a daemon set, say, if you're in a cluster. That way, you're reducing the amount of network between your application and Cerbos, down to even the API design we have. So, for example, Cerbos uses a gRPC interface by default. There is a HTTP version on top, but it uses gRPC to keep the overhead over the wire down as possible. And then for the actual calls themselves, for a small number of requests, you can do batching, but there's the case which, once you get into the more sort of serious type use cases around authorization, you'll quickly run into scenarios where, let's say you want to present a list of all the resources someone has access to inside of your system, but it's only those resources that they're authorized to. What you don't want to do is to go and fetch every single record from your database and do a check one by one and figure out which one someone has access to, because you're eventually going to fetch hundreds, thousands, millions of records, and you're going to reduce them down, and you might have access to none of them, at which point you've wasted all that time and all that compute. That's a bad design, and that's something that we do not recommend. Same time, we don't recommend using anything authorization that requires an internet call. That's just bad design. So again, in Cerbos, with that focus on performance, there's a capability inside of Cerbos where you can say, rather than here's this user, here's this resource, here's the action, should be allowed or denied, you can say to Cerbos, here's this user, here's the resource type they're trying to access, and here's the action they're trying to do. So here is Alex, he's trying to view all the purchase orders. And what Cerbos will give you back is not an allow or deny. Cerbos will give you back an abstract syntax tree of conditions that you need to apply to your database lookup or your Mongo filter or your API call to return just the instances of a resource that user would have access to. So that AST will be derived from your policies, and it will say, the status field must be X, the owner ID must be 123, the active field must be Boolean, etc. And that is an AST which you then convert and map into a where clause or whatever you're using for the underlying data structure. And it solves kind of one of the hardest problems of externalizing authorization, which is this kind of filtering and performance bottleneck you run into.
It's interesting to me, as you went through, before you explained what you just explained, you were talking about all the normal stuff you would expect with RBAC. But then you got up to this one point where, and we have an audit log for everything. That doesn't happen everywhere. What made you want to put in that audit log? Because, grunts like us as developers, typically we don't care about the audit log except when somebody's yelling at us. But
yeah, fair.
Why was that considered to be?
Then we yell back.
But it to me, it seems like that might be one of the initial seeds for the whole thing was the actual audit log.
Yes. So the way we kind of look at sort of logs in general, there's kind of two types. There's one which is like your general, I think data exhaust seems to be the new buzzword around it, but it's basically your standard out logs that your application might be logging, console out, etc., those sort of things, which is a mixture of behavioral data, debugging information, request information, latencies, that sort of stuff, which your existing log collection system will pick up, whether you're using some cloud version or you're sending it to Loki or using Datadog or Splunk or whatever, that data will get picked up, and it's usually quite large in volume and fast moving. And the downstream system they're going to is going to be typically, limiting you in terms of data volume or data retention length, etc. And when the developer gets yelled at and say, "Why is the system not working?" Those are kind of logs, the application logs you go to. You want to find a stack trace and debug things. When it comes to authorization, the actual requirements around logging are different because the requirements are no longer about how can we debug an issue faster. It's more about how can I, as a business or an application provider or a software provider, be able to prove the access controls are in place in our system. And you're now not just kind of proving it yourself. You actually need, if you work for like a regulated industry, banking, finance, medical, etc., you actually have requirements to store these logs for N number of years, 10 years in some cases. And these are now being used for like breach investigations or compromised identity investigations. And really, these audit logs are kind of a side benefit of implementing externalized authorization. From a developer perspective, it's like, cool, all my logic's defined once. I do the integration in my code once, all good, etc. But actually, from a security and a compliance and a product team perspective, these audit logs because the authorization service, the policy decision point is in the path of every request, is the perfect place to capture these logs. And then you send it off to some managed audit log collection service, etc. And it's fully pluggable in the open source project where you send them. But these logs actually serve a different purpose, and they're much more structured, and they're much more focused around what did this user actually do inside of the system, which you need for more of those compliance and regulatory needs. And even just internally in the business, like you got a support ticket coming in, you can now go to someone that maybe isn't a developer to understand why the permission was denied. And it kind of takes work off a developer's plate because these logs are now very clean and easy to understand rather than being stacked dumps and stack traces and such inside of a system that maybe your customer support team doesn't or shouldn't have access to if it's, say, Datadog. These audit logs can be something that's actually useful and usable for other parts of the business that maybe isn't involved in the development side of things and give you that clean view of exactly what happened.
Okay, so audit logs are really cool. I mean, I personally don't care, but other people care, right? And
yes, that's the key
point there. Yeah,
and you don't have to build it.
But the thing and I didn't have to build it. That's the most important thing. But the thing that is cool to me is how policies are stored, or the options we have for storing policies. Mm-hmm. Typically, you're thinking, okay, it's a YAML file. It's just going to be flat on the file system. The PDP, the engine, will slurp it up, and it's in memory, and life goes on. But it goes well beyond that, it appears.
Yeah, so the policy files, these are your source of truth. These are the hard and fast rules of exactly how a system is supposed to be done. And the actual format of those, as I said previously, is just a YAML file. Where you store those is very flexible. It's a pluggable backend in terms of how we built it with the Cerbos policy decision point. And our actually recommended approach for this is to follow all your standard GitOps best practices. So create a repo in GitHub or whatever you use for source control. This is your authorization policy repo. So you get all the benefits of version control. You have a full audit trail of how those policies change because you can see the commits. It goes beyond just having a source of truth. We also make available as part of the project a whole CI type pipeline around it. So your Cerbos policies, as they evolve, you can, as well as having defined in the policies, you can also write tests against them. So you create fixtures as you kind of would with software. So you create example users, example resources, and then the expected actions that they should be allowed to do or not. And then as part of our CI tooling, Cerbos will run the tests. It will make sure your policies are doing as you expect. It allows you to take like a test-driven development approach. So you can run this as part of your CI. You have your work in progress or development branch. You iterate in policies, make sure the test pass, etc. Then merge it into main. And then your policy decision point, when you start it up, you tell it where to get the policies from. And so if you go with like the GitOps style workflow, you'd give it a Git repo location, you give it token to access it, and then you tell it which branch to pull it down from. So you might have your main branch or your production branch that you want in your primary environment. You might have your PDPs running in your staging environment, pull from a different branch, etc. But it's a variable plugger backend. That's the one that the vast majority of users use. But equally, you can just pull from disk. You can give it a credential to a cloud storage bucket, be it S3 or GCS, and you can even point it at a database. So if you want to actually mutate policies at runtime, which is a kind of a use case if you want to allow end users to maybe create custom roles and those sort of things, we support mutable backends. So you can actually connect it to a Postgres database or use SQLite or use MS SQL or MySQL and those type of technologies. And now your policy store is mutable, which if your requirements require that, you can then do. And then the Cerbos PDP exposes an administration API, we call it, where you can put and get and update policies, patch policies programmatically, and then they're stored in the underlying database behind the scenes. So it's a very pluggable backend. We always recommend go with the GitOps approach for all the obvious reasons why GitOps is a good idea, and also ties nicely into that audit story. But it's kind of up to you to decide what makes sense for your architecture and how you like to distribute assets across your application.
The database example just gives me shivers. That just sounds like a bad idea, but it sounds like you had to put it in because somebody probably wanted it. To be honest, it's a fair way of doing things, but if you care about auditing, it's a horrible way of doing things.
Yes, I mean, we have built audit trail capabilities even into the database version itself. So we keep change sets and such, but it is really targeting specific use cases where you run truly dynamic policies. The way that you kind of receive that dynamicism in your policies, but whilst also keeping a strong version controlled set of policy files themselves, is inside of your policies, you're not actually ever defining individual resource relations or those sort of things. The dynamic data comes in at request time. So actually, most of the time, your policies can remain static, can evolve, because all your policy is doing is inspecting attributes that come in from the principal or the resource to make a decision. But for those cases where you do want truly dynamic policies and even end users writing policies to a certain degree, having a database backend does support that. But it's a kind of a trade-off depending on what kind of model you want to achieve.
Now, with it being 2025, we have to go ahead and go into AI stuff.
Oh, yes.
Right. So here's my question in this. We were talking about, okay, here's my identity as a human. I'm authenticated, and then I'm authorized, and then I can do whatever or not do whatever. That all makes sense.
Mm-hmm.
But now we have this whole agentic or AI agent thing.
Yeah.
How is that going to play out? Because used to, this would be crystal ball stuff. It's not crystal ball stuff anymore.
Oh, no, it's definitely not. And we're already getting asks like, how do I authorize my AI agents and such? And so this kind of gets us into the realm of like non-human identities or short-lived identities. We've always had non-human identities. Every time you make an API call, that identity you have isn't a user. It's some sort of like client ID or API client ID. And to your authorization system, be it Cerbos or something else, this is just another type of principle. It doesn't have to be a human. It's just, here's some identifier for them, here's some attributes about them, make an authorization decision upon it. So actually from a authorization engine or a policy decision point perspective, it doesn't really matter if it's a human, an agent, an API user. It's just an identity. I think where authorization and AI intersect, which is more important and more pressing right now, is how you control what the agent can access based on the person that prompted the agent. The concrete use case that we hear over and over and that we've kind of been building around and kind of launch capabilities with is, imagine you are a business and you want to enable your customer teams or sales teams to interact with your business data using like a chatbot or instructing a number of agents via some mechanism to go and fetch data. And the example we keep hearing is like, I want to give my sales team a way to basically get their sales report in a way that's much more interactive rather than just looking at a dashboard. And so you might have sales teams in Europe, you might have sales teams in the US, but you have authorization rules that say only if you're in the US, you can only see data based on your US sales. If you're in Europe, you can only see data based on your European sales. Fairly standard rule. The way a lot of these systems have been implemented up until recently is you would kind of go and deploy this amazing AI agent inside of your stack. And by design, it kind of needs to have like super user access to all your data so it can then come up with an answer. Now, the problem there is someone in your European sales team could say, okay, go and pull my sales report or our sales report for this quarter. If this agent doesn't know who that user is or doesn't have permissions or does have super user access, which it ultimately needs to, you're going to have someone in Europe getting data and results and answers back based on their US data or vice versa, because these agents and these systems have super user access directly to your internal business data. So where authorization and AI intersect really primarily and most kind of concerningly that isn't being done today is how do you pass down the permissions? How do you pass down the authorization of the user making a request to some agent and then that agent acting on behalf of them in a way that also reflects the permissions and controls in place? And there's lots of different approaches to this, RAG architectures, the retrieval augmented generation type models. They're storing your business data in some sort of vector database. Now, these vector databases actually have a way of filtering the results that you pull out of them via metadata filtering. So to go to kind of the early point around how do you limit or control what results you get back from a data set, the same model can apply even now the data set is a bunch of embedded documents, but you can still pre-filter that based on the authorization. So me as someone in Europe, I have rules that say I can only see sales based in Europe. So when the agent goes out to the vector store or goes and queries some data sets, it can pass down those filters and make sure that the data it gets back or the context it's using to come up with a response is actually pre-filtered based on the access I should have as the person making the request. And that is where there's the intersection of authorization and this new AI world in 2025 really need to align, and using something like Cerbos and a policy engine can get you there in a way that allows you to roll out these things sensibly and not start opening up all sorts of new data exfiltration scenarios.
I think with that, it's no different than what we've been dealing with for the past 4 or 5 decades.
Mm-hmm.
It's basically a human makes a request to a service that since it's inside the firewall, it must be fine. Right? And the real problem is these services, now it just happens to be an AI agent, needs to be able to impersonate me.
Yes.
Not just as it's coming in, but it's got to be checking itself on the response. Or it should be, right? We should be, again, using your phrasing, trust but verify. We need to trust but verify from the initial request until the final response.
Yep.
And all the way through that chain. And guess what? As a developer, that is a pain in the butt to deal with. So how do we make that simple? Is there any way to do it? Or are we just resolved for the next 5 decades to still be playing the same game of why are we building the system yet again?
Yeah, absolutely. And zero trust is a lot of buzzwords around it and lots of hype around it. And I find there's actually kind of a lacking of real world implementations in a way that's something kind of off the shelf. I would say for the sort of machine-to-machine authorization and machine-to-machine impersonation, there's great projects out there like Spiffy and Spire as a way of giving identities to workloads and then making sure that whatever authorization system you're using behind the scenes can know how to verify not only the workload identity, but also the credentials of the user that it's impersonating. So how you pass down essentially the certificate chain or the token chain. Okay, here's this workload identity, here's who's calling it, and it's calling it on behalf of this user. And you need to make sure that the authorization layer, the policy decision point you're using, knows how to inspect both the types of that information. So like we even do this inside of Cerbos today. Every request comes in, we know which service is calling it, but we also know who the user that the call is being made on behalf of is, and then we can verify that both to make sure that service should be allowed to call some other service, but also that the user that originally prompted the first service can do it. So it's all about having that flexibility and inside of your policy language, being able to inspect all those attributes, both of the calling service and the impersonated user.
Can we externalize some of those things in a way so that I, as a developer, do not necessarily put too much logic into code? So let's say a database, right? I think, correct me if I'm wrong, if I understood right, earlier, I can get a list of conditionals and then I can go through my data set that I retrieve from the database and choose what to show, what not to show, right? Can I theoretically at least put that out and say, let's say a sidecar, right? And say, actually, I can rely that the data set that I'm going to get is okay in the first place.
Yeah, so this kind of goes into what we've been talking about a lot now is like fine-grained authorization, which is like really down at a single request level to a specific resource, should the access be allowed or not. There's also kind of, I wouldn't call it coarse grain, but like medium grain authorization in the middle. And we see this being used a lot at kind of the API gateway level. As a request comes in, typically if you're using one of these gateway systems, it allows you to do kind of cross-grain authorization in the sense of checking that there's an authorization header that has a token in it, and that token is valid. And you can do some sort of basic checks there. And this is where you can do your higher level role-based checks. You can do contextual-based text based on the path, the headers, even the request body before it even hits the service. So as a developer building the underlying service behind the gateway, there's a certain assumptions you can make. You can now know that once the request hits it, that it will have a token. That token will be valid. You can make reasonings around, okay, this user will be able to hit this path. So you can kind of obviously re-verify, but you don't necessarily have to put all the checks in there. And you can abstract some of the logic up. To do the real fine-grained stuff, though, where you're looking at individual instances of a particular resource, you really do need to be very contextual, and the check really has to happen inside the request handler level, because that's where you have the full context of user, resource, plus the actual request context, IP address, time of day, that sort of thing. And then pushing it down to the database level, that is always going to be dynamic. There's a model that we see some users trying to implement where I just want to send a query. I want some sort of middleware service that mutates that query, goes to the database, and then on the way back from the database, it then filters the data down. I personally don't think that is kind of a great design, because in theory, you're going to be overfetching from the database and then filtering on the way back out. I think it's better to apply your filters up front and then leverage the powerful query engines that all these databases have to actually just return the records that you should. But that may not always be possible if there's kind of filtering you it's maybe not be possible in SQL, or you're hitting some external API that doesn't necessarily give you the right controls, there is an argument where doing a filter on the way back can make sense, but it's not going to be as performant as front-loading all the filtering and authorization checks on the way out, as it were.
There is no query that cannot be done by SQL.
Well,
some people will argue that it can, but that's not.
There is no query that cannot be done. There are queries that can bring down your system.
Well, true.
yeah. It comes back to a performance trade-off in the end.
So if I wanted to get started with Cerbos, what do I do? I'm ready to just get started. So I'm not doing let's say that I'm going to build a just simple internal application.
Yep.
Right. No big deal. I've already got SAML hooked up, so the authentication is fine. Right.
Yep.
So all that's fine. But now, what pieces do I need to do? Do I actually have to have Kubernetes? Do I have to do, because I'm in a place I don't use Kubernetes, I don't use Docker, I don't use any of that. Is Cerbos still a thing for me?
Sorry for interrupting. If that's the place you are in, Darren, you should leave.
You can go and continue, Alex. That was his just kind reminder that I'm still stuck in the 80s. Okay.
So there's a bit of a wishy-washy answer first, that we actually find that 90% of the effort is just getting agreement on what your authorization logic should be, or getting it down on paper. So we actually recommend, before you even think about implementing or writing some code, go and draw up the spreadsheet of user roles and actions and what should be allowed or not, and getting alignment on that. Obviously, if you're building an internal application yourself, you should know this, but having that first, converting that to a policy is pretty simple. And then tactically, what's involved, you need to run the Cerbos policy decision point somewhere, and you need to have somewhere to store your policies. If you're just getting started and you want to kind of iterate quickly, create a folder in your source code repo that contains your policy files, and then you can start a policy decision point. You can grab this just as a release on our GitHub repo, github.com/Cerbos. We publish binaries, and we also publish a container. You may not use Kubernetes, but if you just want to start a Docker container up, equally, you can just do, if you're on a Mac, homebrew, brew install Cerbos. We try and make it available everywhere we can. And all you do when you start it up is you say, okay, here's my policy files. Great. And then by default, it will start a gRPC or an HTTP server on the ports. And then for the integration, if you're using one of the common languages out there, a good chance we have an SDK for it. And then in your application code, where you want to check permissions, rather than hard coding it, you just go, Cerbos, here's a principal, here's a resource, here's an action, and it will return back to your code path, either an allow or deny. You don't need to touch or configure anything kind of beyond that. So we try and make it as easy as possible. Even if you wanted to get started even before then, and you just want to kick the tires of writing policies, we have an online playground, which you can find at cerbos.dev, where you can just try modeling out what your requirements are without having to spin up a single thing on your local machine.
So the first non-alpha release was in May of 21.
Yes.
So right in the heart of the pandemic.
Oh, yes. We're a COVID company.
Yeah. Here we are almost 4 years later. Are you where you think you would have been in 4 years? Do you feel like you're behind? Do you feel like you're reasonably on track? And where are you wanting to take the project now?
So with the open source project, I would say we're in a better place than I thought would be, actually, because of the community contributions. So we always had this good idea in terms of, okay, we want this all engine, we want it to be performant. And the first few versions, we had an engine, we got it to a place where we kind of got acceptable performance, and really a lot of the iteration has been since then to kind of make it as fast as possible, shaving off nanoseconds. We're talking here, looking at the traces. But a lot of the capabilities, so we talked about audit logs and where you send them. We now support multiple audit log backends, of which, for example, the Kafka sync was contributed by a company that's using Cerbos today back to the open source project. The storage backends, we now support cloud storage buckets. That was another contribution. So actually, there's more features inside the open source project than we thought we would have at this point, just because the community is kind of contributed in the back, and we obviously kind of encourage that. We've also taken the policy format itself into a few different directions. So we now have policy types that we never really imagined we would have. So you can now create policies that define custom roles in a way that's much simpler than having to mutate all the underlying policies. And that was driven again by users. So the project isn't where I think it was, but it's actually I thought it would be. It's actually in a better place, in a different place than I thought it would be at this point. And I guess that's the beauty and the benefit of open source, and why we made that decision very early on. Let's make this thing accessible.
Just looking at the basic architecture diagram, it looks like all the pieces are already in place. Is there anything else big coming in from a project perspective?
Yeah, so in the open source project, we're really iterating and evolving on right now is making it easier to model custom policy requirements. So we have a kind of very structured way of defining policies now. You have your resource policies, you have principal policies, which can override conditions for certain distinct user IDs. We have things like derived policies as well. Where we're going is adding more policy types that make it easier to rationalize around things like custom roles or being able to use like environment variables inside of your policies and those sort of things. So all the iteration you'll see on the open source project today is all about making it easier to model your authorization policies without having to necessarily go through too many hoops or logical hurdles to model things. We have quite an opinionated way of how you write policy. We're allowing kind of different models in there. And if looking at the repo, you would have seen at the end of last year, we merged in custom roles and authorization policy strategy support. So you can actually change slightly how the engine evolves things to match different use cases, which we never originally designed for. So a lot of the work and a lot of the open source contributions we're getting as well is really about how can I really model my business requirements in a way that doesn't require me to change too much logical thinking and model it in Cerbos in a sensible way.
Now, we've been talking about the open source project. What about Cerbos, the company? Why would I even need to deal with the company part of this?
Yeah, so if you listen to this, you're well in the world of DevOps and you're perfectly happy running CI pipelines and setting up integration tests and managing deployments, etc. But from our open source usage over the last 4 years now, we got a lot of feedback, which is, I want to use this, but I now have to, set up a pipeline. I now have to worry about how my policies get distributed. I now have to worry about how I go and collect my logs. I want to give a UI to my product managers or security teams to view those logs. And these are all things that you can absolutely do with the open source project. There's nothing that stops you. But what we've built is Cerbos Hub, which is a management control plane, or to use the formal policy terminology, is a policy administration point. And the way this works is the policy decision points are running locally in your cluster. So you get that performance, you get that local decisioning, but the administration you can do centrally. And so Cerbos Hub is our managed SaaS offering, which you connect your policy decision points to, and then it is a fully managed CI/CD pipeline. It's a whole policy IDE environment. We enable you to actually do authorizations on the edge or on device, even using a WebAssembly version of our bundles. And it's also a collection point where all your individual decision points will get back the audit logs, and we present that in a UI that you could then hand off to your customer teams or your security teams to use. But there's nothing built into that you couldn't do yourself purely with the open source project, and we want to be very clear with that. We've even open sourced the API that is used to talk between the decision points and the control plane, so you could go and implement your own control plane if you want. So it's a complementary product. It's not a proprietary version, as it were.
So Cerbos can be found at cerbos.dev. That's cerbos.dev. All of Alex's contact information will be down in the episode description. Alex, thanks for being with us today.
Thank you very much for having me.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.